Hi folks, Scrubbing Bubbles here, and this pre-calculus lesson is called the Law of Sines. This is a nice quick lesson, I think, you guys. So let's go ahead and take care of the board problem here. I'm taking out the board problems just to save some time. That's what I did right there. So no more board problem for a while. Okay, so the law of sines, let triangle ABC be any triangle. It doesn't even have to be a right triangle with sides A, B, and C, and small a is always opposite the angle A, and small b is opposite the angle B, and small c is opposite the angle C. Okay, and so what happens is you can set up these proportions right here and use your cross multiplying and solving right there. So this goes really slick, you guys. Check this out. So solve this right triangle, or solve, it's not even a right triangle. Solve triangle LMN if L is 29, M is 112, and L is 22. Okay, well, first of all, I can figure out this angle right here because 180 for a whole triangle right there, so I can figure that angle right there is 39 degrees. And then I just use the sine ratio. Just remember the sine of 29 over the side that's opposite 29 equals the sine of this angle over the side opposite that is m. Okay, so you can go ahead and uh, and then you can also do the sine of 29 over 22 equals the sine of 39, which is this angle, over this side right here. And then cross multiply, and you should get the m to be about 42.1 and n to be about 28.6. So for example, on this one, I would go sine of 29, find the decimal, multiply that times m, so it's going to be some decimal times m, equals this decimal, sine of 112, divided by times 22. So you multiply these two guys together, and then you divide it by whatever that decimal is, and that'll get you this m right here to be 42.1. And then do the same for this one to get 28.6. Okay, it goes really fast, you guys. So here's an example of a word problem right here. It says a baseball fan is sitting directly behind home plate in the last row of the upper deck at Comiskey Park in Chicago. Is that how you say it? I don't know. The angle of depression to home plate is 29 degrees 54 minutes. I'm going to change 54 to point degrees. So 54 divided by 60. And the angle of depression to the pitcher's mound is 24 degrees 12 minutes. Okay, so in a Major League Baseball field, the distance between home plate and the pitcher's mound is 60.5 feet. So how far is the fan from home plate? So here's a picture right here. Okay, so he's up in the stands right here, and he has this angle of depression right here is 24 degrees and 12 minutes to the pitcher's mound, and he has this angle of depression to home plate to be bigger, 29 degrees and 54 minutes right there. Okay, so what I'm going to do right here is I'm going to find out this angle right here by taking the big angle and subtracting off this angle right here. Okay, and I find out that angle theta is 5.7 degrees. Now remember, this angle of depression is the same as this angle of elevations because they're alternate interior angles. So this is 24.12 degrees also. Okay, now I know that this is 5.7 right here. Okay, and I know that this is 60.5. So I'm going to go the sine of this angle over the side opposite that equals the sine of this angle over the side opposite that. Okay, and what I did also, you guys, is I took, let's see, I took this 54 minutes right here, and I did 54 divided by 60, and I got 0.9 minutes. So that's where I got this 29.9 right there. And I took 12 and divided it by 60, and I got 0.2. So that's where I got the 24.2 right there. And that's where I got the 5.7 right there. And I set it all up. And then, so I get the sine of 5.7 is 0.099. And then the sine of 24 and the sine of 24.2 is 0.410. So then I cross multiplied this times this equals this times this, so I get this right here. So I get, he's about right here. This distance right here is about 250 feet from home plate right there. Okay, and I did the law of sines with this little triangle right there. How's that? All right, so let's try this. So let triangle ABC be any triangle with sides A, B, and C, and then the area, and I don't know why, but this book calls the area the capital letter K. The area of a triangle can be found two ways. And actually, there's more than two ways. I'll show you in the next lesson right here. There's more than two ways. There's actually In this case, there's 3 ways, but and what you do is your area, this is area, equals 1/2. If you're doing the sine of A, then it's the other 2 sides that's not opposite A being multiplied. If you have the sine of C, then it's going to be A and B. If it's the sine of B, then it's going to be A and C. So big letter doesn't have the small letter in here right there, okay? So that's how I set it up right there. And then we'll use this one in the second part right there. So this is if they give you only one of the sides and you know all 3 angles, or at least know 2 of them, and you can do 180 minus the 2 of them to get the third one right there. All right, so let's try some of these, you guys. So here I have find the area, and I have this angle right here to be 25 degrees. I have this to be 21.2, and this to be 16.5. So I'm going to do K equals 1/2 the 16.5. So I'm using this formula right here. I got angle A. They're all the same right there. These are all the same. Just depends on what they give you right there. So I'm going to do this angle and the 2 sides that are surrounding the angle, and then take half of that. Okay, so it's going to be half 21.2, sorry, this should be a 0.2 right there, and then 16.5, so that should be a 0.2. Okay, and then 16.5, and then take this and sine of 25, and then multiply all that out, and you get about 73.9. So the area is about 73.9 units squared. Remember, area is always units squared. Okay, how about this one right here? Okay, I got these angles right here. Now, since I don't have the included sides right there, what I'm going to have to do is figure out angle J first up there, and then do angle. Okay, so let's find angle J first, you guys. So let's find angle J. Angle J is 41.6 because I did this one plus this one and took it away from 180, and then I did. This other ratio right here where I have the 2 angles and I only have one of the sides right there. So I chose to do, it doesn't, these are all the same formulas right there. So it's 1/2 the sides squared, and then you do the angles right there. So that's where I get all of that, and you get about 673 units squared on that. Okay, nice and easy. You just got to get used to using the formulas, and it gets nice and easy once you get the hang of it.